Hi everyone, and welcome back to Fundamentals of Engineering with Farhad. Hydraulic design, severe system design. So in this example, we want to review the manhole or maintenance hole in severe system. So if this is a manhole, a concrete pipe beneath the earth, we want to calculate the top elevation of this maintenance or manhole. So the location of the invert elevation is at the feet of the standing man. As you can see here, we call this point the invert elevation of a maintenance hole. So we are provided with the diameter and thickness of the cover of the concrete pipe or wall. And if you add up the invert elevation, so this is the invert elevation plus the diameter of the pipe minus the thickness. We reach to the top of the maintenance hole manhole from the invert elevation. So let's jump to our multiple choice question to see how we can calculate the top elevation of a proposed manhole. We have like we have a concrete existing pipe which connects the two manhole. This is one of them, this is the other one, and we want to create the third manhole in between these two. If the specification of the proposed manhole is the diameter of 16 inches concrete pipe and a cover or thickness of the concrete manhole is 6 inches, and the invert elevation and a station for the two available ones are provided. Ground elevation and also station for the proposed new manhole are provided. We want to know what is the top elevation of the proposed manhole here. So in this example, if we consider our three manholes, like if we connect the invert elevation of the two existing one, and create this triangle which also passes through the proposed new manhole, we have the invert elevation of the two existing one, and also the station for the two existing. So let's make it more pronounced. We have like the invert elevation for this one, that's 630.32 feet. If we subtract it from the other existing manhole, which is 609.39, we get the height difference between the two existing manhole, that's 20.93 feet. And also the station for the one of the existing manhole is 23 feet, the other one is 288.4 in terms of feet. So if you subtract that one, it just gives you the length or the distance between the two existing manhole is 265.4 feet. So rise over run is the slope of this line, so we can get the slope of this line, and the location of the proposed manhole is at the station 115 feet. So if that's the case, if we subtract these two stations, we can get the length difference between the proposed one and one of this existing one. So it just gives us a length of 173.4 feet. And definitely, if you rise that distance by the slope of this line, definitely you will get the height difference of these two invert manhole. So it says if we have the invert elevation of one of the existing manhole, if we add it to the rise of elevation, we can get the invert elevation of the proposed manhole. So in such case, invert elevation of the existing one plus 13.67, which is the height in rise in elevation, we can get the invert elevation for the proposed new manhole is 623.06 feet. So, and as soon as we have the invert elevation, we can move back to our manhole equation. So invert elevation plus diameter minus the wall thickness. It just gives us the top of the manhole, which is what the question is asking us. So convert everything into feet because this elevation or invert elevation is in feet. It just comes here 623.06 in feet. Diameter of the manhole is provided to be 60 inches divided by 12 to get the feet, and the cover which is provided in problem statement is 6 inch, so that's a half a point 5 feet. And if you do the math, it just gives you the top elevation of our manhole, which is this point, is 627.56 feet. If we jump to our multiple choice question, you can easily see the top of our manhole is 625.56 in terms of feet. So that's choice B. Thank you. We'll solve more example in severe design.